Welcome back to our channel Active Catalysts. In this video I'll be explaining you the second module of CN. Okay, in this module we will come across different kinds of headers, the protocols and few numericals as well. Don't worry, it's easy. Okay, so let's get started. Before I start, I have already recorded module 1 video, you can check out. And as you know, we had discussed in the group that we will be allocating only 2 days for the CN. So from today we'll be starting SCPM. Meanwhile, we will pause the CN. What is the idea for that? I'll tell in the end. But now let's concentrate on this module. So solve using CRC. This is a 7 marks question. In the question, they'll give you the code word and the divisor. Okay, so whatever code word is there, right, that you should write inside. Okay, 1001, and the divisor, you know, we will write it here. Okay, now what happens is, see, it's easy if you understand clearly. So listen carefully. Okay, so in this all 4 digits, which is the first digit? 1, right, here. So 1011, you will write 1 here. So something into 1 is that only, right? Like 1 into 1 is 1 only. Similarly, 0 into 0 is 0 only. Something like that. If you multiply same numbers, you will get the same value. Okay. So 1011 one time is the same value. Okay, now normally what we have to do is, while minus or subtracting, you have to follow XOR gate. That is, if both are same symbols, answer is 0. See here, both are same symbols, right? So answer is 0. If it is different, like 0, 1, then answer is 1. Okay, so you will get some 4 digit of number. Next step is, you should remove this 0. Okay, and this whatever 3 zeros we should add extra. Remember, in CRC, whatever question they can give, we are going to add 3 zeros extra. So in first step, you will bring 1 0 down. Now you will get 0 1 0 0. Now same thing, which is the second digit here, 0, right? So now you have to write this 0 here. So 0 into 0 is 0. So all whatever you take will become 0. Similarly, you will get one answer. Cancel this 0. See, in every step, you are going to cancel the last zeros, whatever you get. And take down 1 0 down. And follow the XOR operation. Okay, it's simple. In the last step also, you should remove 1 0 and you will get some remainder. Okay, now we have to check the code word uncorrupted and corrupted. How to check that is, okay, kindly adjust with the camera and all, because I have to hold the phone in the left hand and record or teach in the right hand. Okay, so code word is nothing but whatever these value they give, right? Code word, that is the code word, right? So I've written this code word. Whatever answer you get, 110 remainder, that should be written here. Okay, now what happens is, this entire thing you're going to write inside, and whatever is the divisor here, 1011, same thing you will write and you will get one answer. See, remember, if you get all 4 zeros, then it is called as zero syndrome. Okay, now here what you are going to do is same thing only, but like this is just like checking. Okay, corrupted, you are only corrupting it, you are only changing the value. What value you are changing? See here we had 1001, right? So I'm making last digit as 0. I am only changing, I am only corrupting it. Okay, like that you should understand. So same thing again you will divide, but answer this time you will get something different. So this is called as non-zero syndrome, and hence this is wrong. So data word will be discarded, and this data word, since we are getting all zeros, that will be accepted. Okay, next we have write S-frame format of HDLC and explain individual field of it. I'll remember you again, don't study anything extra, because all extras also have added. Like first 10 questions you can consider it as compulsory, and remaining, if you want to score, you will study. Okay, yeah. So we have 3 frames. Okay, I, S and U frame. Remember, I is information frame, so it will store the information regarding user data and it will control the information of the user data. And S frame is the supervised frame, so it is used to transport controlled information, whatever information here we have, right? So supervised frame will transport that information, and unnumbered frame is for system management. So if I want to say I frame will store the user data, S frame will control it, supervise it by transferring, and unnumbered is going to manage the system. Now this is how it actually looks like. Okay, now the trick to remember is, remember in ISU, in all three frames we have flags in the end. Okay, flags. And we also have address and FCS. FCS is nothing but frame check sums. Okay, so we do have all these three things, and even we have control. The only difference is in I we have user info, in S we don't have, and in U we have management info, because we already know information frame is going to store what? User info, and supervised frame it is just used to transport, so nothing is necessary, and user the U, that is unsupervised, we need it for managing the system ashte. Okay, then we have to explain each field. Like, see, here we will be explaining generally. There is also a question where they have asked explain specific only with information frame. Like that, if they ask, answer will differ, but here you can write generally. Okay, so yeah, flag field, you can see flag field. So it is an 8-bit sequence with bit pattern. Now how we will identify whether it is flag field only is, remember we will have 8 number of ones, and in last and end we will write 0. That means it is flag field. Okay, so that this is the beginning and this is the ending. So beginning and ending of a frame, and serves as a synchronization pattern for receiver. Like if I receive this, imagine I'm receiving this data. Okay, by looking at this I can see there is 0 in the starting and 0 in the ending. I will understand it, right? So that is how I can synchronize it and understand. So synchronization pattern. Then address field. So in address field mainly we have primary and secondary station. Primary station is to stores to address, like for whom you are sending. Secondary address will have from address, from whom it is getting shared. Okay, so it can be either 1 byte or more depending on the network we are using. Remember, flag will have 8 bits and address will have primary and secondary. Primary will store to address and secondary will store from address. Similarly, we have control field. So this can be 1 or 2 byte segment of frames used for flow and error control, right? So flow and error control. Then comes information field. So it contains what I have told, users info, right? And its length can vary depending on the length of information, right? Then we have FCS field, that is field check sequence. I think I told something like frame checksums, even that is there, but here it is field check sequence. Okay, yeah, so it's error detection field, check, it is going to check errors, and it can be 2 or 4 bytes. It is important for you to remember like how many bytes and what is the role of it. And again, once I have written control field, because control field varies. Like we have control, this control field is specific for something, this is something, and this is something. So I've written one more control field here. Yeah. So it determines the type of frame and defines it functionally. Like now how that control frame can vary, I have written in 3 different things. So I frame will look something like this, right? If the starting is 0, okay, we will understand that it is I frame, and S frame is understood if it is 1 0, U frame is understood by 1 1. Okay, and remaining in middle you can see it is P by F, a pole and field. Okay, P by F. Remember, here it is NS NR, here it is only NR, and here it is code. Okay. Now same thing I have explained it in the words. Better if you remember this table. Okay, so how do you identify? There are mainly 4 kind of frames. RR is receive ready, RNR is receive not ready, REG is reject, and SREG is selective reject. This table they have not given in textbook nor in notes. They have given it in words, but I have made table so that even for you it will be easy to remember. Okay, then third question is slotted aloha and this pure aloha. Okay, I'll tell you in simple. Okay, I'll not just read this. If you want, you can read this. I'll just explain how it works. See, aloha is something like you're going to transmit the data through that. It is just like one railway station, and from that railway station packets are getting transferred. So in case of pure aloha or simple aloha, the packets can arrive at any time. So there can be traffic, there can be congestion, network traffic can happen, there can be collision, and it is less efficient. Okay, you can compare just like for aloha you can compare train, railway station, and for slotted aloha you can compare with something like I think metro. Imagine, okay, just imagine. I know metro is also rush, but still you can imagine like metro is having less traffic, like that you have to just to remember. Okay, so like that you can say. And here you have to remember three main things, that is three main values actually. So vulnerable time for aloha is 2 into capital T and small t. For this it is TT. And this one you have to remember, probability of successful transmission G into e power minus 2g, and this is this thing. Maximum efficiency also you have to remember. Efficiency, there are 2 points here. One you can say less efficiency and mention the value. Like don't write it like one after the other, write somewhere different like this, how I've written, so that invigilator will not understand that you have written efficient related 2 points. Okay. Next comes bit oriented and frame pattern and all. So bit oriented is nothing but the data section of frame, like if you are interrupting with bits or changing something with bit, that is only bit oriented. Now like you have to show it how that bit oriented happens. See, obviously we will have flag values and we will have header, trailer, and this is the bits that is going to vary. So variable number of bits. Okay, and we will obviously have different datas above it. Okay, now let us understand bit stuffing and unstuffing. Okay, I have written both the diagrams as given in the textbook also. Bit stuffing is nothing but, listen to me carefully, you are going to add some extra bits. Okay, you're going to add what? Extra bits whenever you encounter some special characters. For example, flag. Flag is a, inside flag is a special character for you. If it is outside, it is not. Okay, so and escape character is also a special character. So whenever you encounter this, you are going to add the extra byte. Why I have written byte here? Because in question they have asked what is bit oriented, and they've asked you to explain byte stuffing. Bit and byte is a different thing, right? Yeah. So yeah, you're going to explain it by adding extra. If you stuffing it, right, you are stuffing some vegetables in what is that, burger, and similarly unstuffing is removing. So byte unstuffing is whenever you encounter escape character or this escape characters, you're going to remove it. That is only unstuffing. Simple. By looking at diagram only you'll understand. Draw it. Okay, just by looking you'll find it difficult, but once draw. And one more thing I have to tell, as I'm making the videos, it's not like I'm learning and teaching. Just if you look also, it's easy. CN is easy. Okay, let's have that thought in the mind and just continue. And I've written definitions for you. Then, okay, flow diagram for CSMA or CD, very important questions. I'll just tell you what happens. See, there is one value that we are going to consider. Okay, there is one particular station where frame will be sent, that is k equal to 0. If the channel, if I'm free, I'll take it. Okay, if it is true, if I'm free, I'll take it. Okay, but it should wait in IFS. That is, you already know what is IFS. Okay, so once it waits, it will choose for the random value starting from 2k minus 1 to rth slot, and it will send RTS. See, remember it is wait IFS, send RTS. We will set the timer, and if timer receives before the reaching time, then it will again have to wait, because it is coming before only, right? It has to wait, and again send and again send. So this is how we are going to draw it. Okay, so this is how it will look like. I think more than explanation, it's all about studying. And same thing you have to explain whatever I have explained right here. These three things were mentioned in the this thing. What is that? Scheme of evaluation. Okay, what you have to stress is IFS, okay, and this contention window, and the acknowledgement that it is going to get. Here is the, where is that acknowledgement now? Okay, yeah, whatever k value you get, right, that itself is the acknowledgement here. See, same thing I've written in like IFS, that is interframe space, it will be idle before transmission. So then collision avoidance and priority control can happen at IFS. Okay, it is just a station or a space. Then interconnection window, it is randomly it will be waiting for something to come. And acknowledgement is confirmation and successful, like you acknowledge, right? If someone is okay, let us assume that you have ordered something from Amazon, you will acknowledge them, like you will give the OTP, right? Sometimes if you receive the product, something like that will happen. That is only acknowledgement. Then PPP we have. Okay, so PPP is point-to-point protocol, which is in data link layer. So it is used to establish the direct connection. And for the services, you can remember this FN PAAM. Okay, FN PAM. So F is format of frame, N is negotiate, and P is payload, and this A is authentication, and one more A is, I think, where is it? Yeah, address, and M is multilink. These all are easy. If you remember that main words also, you can write the answer. You can just take the screenshot of it if you want. Okay. Yeah. Sorry guys, if the if the video is getting something like handshake thing. In reality, my hands are shaking. Sorry for it. I can't change the hand also. Okay, anyways. Redundancy is nothing but something is getting repeated. Okay, and that repeated thing only we will understand. Okay, something is extra, or something is we are going to detect. That is redundancy. Similarly, they have asked CRC encoder and decoder option. Encoder is nothing but whatever data word we give, right? So same thing will be there, and something we are going to generate. That is only remainder. That is from sender side. Now in receiver side, what will happen is, okay, whatever data word we have, we will write it as it is. If it is correct, it will get accepted. See, always sender you should do like this, receiver it is like this. Okay, if it is correct, it will accept. The decision logic will decide. If it is correct, it will accept. If not, it will discard. This is discarding. Okay, simple one. And for this question also, you have to give the example of this one. You have to solve the same example you can write. Then comes flow and error control. Stop and wait protocol. Actually, this is even there in third module. Okay, still I'll explain it here only. So flow control is nothing but in a flow there will be some packets movement. So if there is any mismatch between the production and consumption rate at sender and receiver side, flow control will detect and match it. Then error control is nothing but it is to prevent that receiving node is receiving the correct data. We had it right in first module. Do you remember that the characteristics of the data communication we had? Delivery, it should be received in right destination. Yeah, same thing. Then comes stop and wait protocol. Okay, so there is a sending node and there is a receiving node. I will explain in a simple way. Later you can refer this diagram because I understand that even I have not drawn it clearly. Stop and wait is nothing but assume that sender is sending the data. So let us assume that this data is getting shared and this is going in this direction. It will receive, it will stop, it will send back the acknowledgement saying that I have received this data. Once it sends the acknowledgement, later if it wants to share any data, it will send. I'll repeat again. This sending node will send. Receiving node, once it receives, it will say, yes, I have received. And it will wait, and later again if it wants to send anything, it will send. Okay, that's what happens. Now in stop and wait, during wait, there must be some state called as finite state machine. In finite state machine, we have ready and blocking stage. Ready is nothing but in ready place there will be one sending node that is going to send the packet. Okay, it will get started and it will send. Now in blocking, if time is out, we can resend it. Also there is something called as corrupted acknowledgement that we have to write, and error free acknowledgement. These two things you have to write. And receiving node also we have. This is for sending node. In case of sending, what will happen? At receiver side, what will happen? Even at the receiver side, we will have ready, because it should be ready to accept. Okay, same thing you will write, corrupted and error free. Same thing. This only you will write, but reverse it and write in receiving side. Ashte. Then we have explain control field of ISU. You already know, right, like what will be there in ISU, but little different you have to write. This time you should be specifically write like what is 0. 0 it is used to identify, it is I frame, and in S case it is 10 is you identify S frame. So same thing you will write. And what is the name? Like NS is nothing but send sequence number, NR is receive sequence number, PF is pole or final bit. Same thing you are going to write. Everything is same. Okay, so then comes a Hamming distance, and Hamming distance is nothing but it is a difference between corresponding bit that is represented as d of x comma y. Now I'll teach you how to write the Hamming distance. Though they will ask it for 1 marks, it is still important. So before I teach, you should know how it works. Okay, and they have asked minimum Hamming distance definition also. It is the smallest Hamming distance value. That's it. So just like how we have seen this thing, right, in CRC, same thing illu kuda, but in the last you are going to add only 1 bit. Illodi, here we added 3, right? Here you are going to add only 1 bit. See, every subject, everything will be easy. Meanwhile, you should have the mind of studying it, the tricks to make it ashte. Okay, so 1 bit in extra ಆಗ್ತೀವಿ, ಅದನ್ನ parity check ಅಂತ ಅಂತೀವಿ. What is this parity check? I'll explain you. Before that, ಇದೇ ಕ್ವೆಶನ್ ಸ್ಕೀಮ್ ಆಫ್ ಇವ್ಯಾಲ್ಯೂಯೇಷನಲ್ಲಿ ನಾನು ನೋಡಿದ್ದೀನಿ, ಅಂದರೆ ರಿಪೀಟ್ ಆಗಿರೋ ಕ್ವೆಶನ್. ಸೊ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡಿ, ಆ್ಯಂಡ್ ಇದೆರಡು ಬರ್ದಕ್ಕೆ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ 2 marks. So please look into this. Okay, so generation of redundant bit. Redundant andre enu? Extra bit. So redundant is nothing but R0 alva. So R0 equal to A3 A2 A1 idan compulsory agi baribeku. And checking of syndrome bit andre illirutte. Okay, so yeah, idu banbittu S agbeku. Syndrome bit B0 B1 B2 plus B3. Okay. Okay, almost in the end, don't worry. Framing andre enu andre, it is nothing but removing the bits in the form of signal is framing. Okay, from source to destination. And character oriented framing anta bere ide nodi. Bit oriented is different, byte oriented is different, and now we are seeing character oriented. Ivaga nodi, like I'll just explain how you have to write the answer. In the starting, we used to only transfer the zeros and ones, binary digits. It was easy. But now, as the days went, we had to transfer text, videos, audios, graph and all. For that, there came the concept of character oriented framing. Ashtu bardre saku, and just explain the each field, what data it will contain. Then there is single and burst error. See, up to 10 questions you can take it compulsory. From 11 it's your choice. Okay, single and burst error is nothing but if only one data is getting other. Let me say I'm sending this data, okay, this data, and I'm receiving this data. So if there is only one difference, I can say it is 1 bit error. If I'm sending this, I'm receiving this, there is multiple difference, so burst error. Then services of DL layer, you can remember it as FPFF. Okay, framing, physical addressing, error and flow control. Then there is handshake authentication. They have asked this question. Handshake authentication anta third module allu barutte, fifth module allu barutte, which is completely different. So don't get confused. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಹ್ಯಾಂಡ್ಶೇಕ್ authentication-ಅಲ್ಲಿ there will be 4 things. Okay, ಒಂದು that is called as challenge bit, another is called response bit, another is called success bit, and another is failure bit. ಸೊ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ದಿಸ್ ಡಯಾಗ್ರಾಮ್ ಇಟ್ ಇಸ್ ದೇರ್ ಇನ್ ದ ನೋಟ್ಸ್ ಆಲ್ಸೋ. ಇಲ್ಲಿ ನಾನು ಯಾಕೆ ಎಂಟಿ ಆಗಿಬಿಟ್ಟಿದ್ದೀನಿ ಅಂದರೆ ಸೇಮ್ ಥಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್. ಓಕೆ, ಸೊ ಚಾಲೆಂಜ್ ಬಿಟ್ ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ, ಸೊ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ಪ್ಲೀಸ್ ಲಿಸನ್ ಟು ದಿಸ್ ಕೇರ್ಫುಲಿ ಬಿಕಾಸ್ ಐ ಹವ್ ನಾಟ್ ರಿಟರ್ನ್ ದಿಸ್. ಇಫ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ಸ್ ಈಸಿ. ಓಕೆ, ಹ್ಯಾಂಡ್ಶೇಕ್ ಪ್ರೋಟೋಕಾಲಲ್ಲಿ ಫ್ರಮ್ ಯೂಸರ್ ಟು ಸಿಸ್ಟಮ್ ಇಫ್ ಯು ಆರ್ ಶೇರಿಂಗ್ ಸಮ್ ಡೇಟಾ, ಆಬ್ವಿಯಸ್ಲಿ ದಟ್ ವಿಲ್ ಬಿ ಎನ್ಕ್ರಿಪ್ಟೆಡ್ ಡೇಟಾ. ಸೊ ಆ ಎನ್ಕ್ರಿಪ್ಟೆಡ್ ಡೇಟಾನ ಡಿಕ್ರಿಪ್ಟ್ ಮಾಡಬೇಕು ಅಂದರೆ ಯು ಶುಡ್ ನೋ ದ ಪಾಸ್ವರ್ಡ್. ಬಟ್ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ವಿ ವಿಲ್ ನೆವರ್ ಸೆಂಡ್ ಪಾಸ್ವರ್ಡ್ ಡೈರೆಕ್ಟ್ಲಿ. Okay, in the system only, that is in the challenge bit only, both user and the system will have some stored passwords. So whatever stored password is there, it is going to check from both the sides. If it is correct, the data can be decrypted. So hagagi we have challenge, response, success and failure. Challenge is it will have the password, both will have, and response it will get the response, it will wait. It can be success or it can be failure. ಅಂದರೆ ಆ ಪಾಸ್ವರ್ಡ್ ಸಿಸ್ಟಮಲ್ಲಿ ಇದ್ದರೆ ಸಕ್ಸಸ್, ಇಲ್ಲ ಅಂದರೆ ಫೇಲ್ಯೂರ್, ಆ ಥರ. ಓಕೆ, ಸೊ ಪಾಸ್ವರ್ಡ್ ಇಸ್ ಕೆಪ್ಟ್ ಸೀಕ್ರೆಟ್, ಇಟ್ ಇಸ್ ನೆವರ್ ಸೆಂಟ್ ಆನ್ಲೈನ್ ಆ್ಯಸ್ ಹ್ಯಾವ್ ಟೋಲ್ಡ್. ಇಷ್ಟೇ. ಓಕೆ, ದೆನ್ ಮೋಸ್ಟ್ಲಿ ಲಾಸ್ಟ್ ಕ್ವೆಶನ್ ಅನಿಸುತ್ತೆ. ಲಾಸ್ಟ್ ಒನ್. ಸೊ ಇನ್ ಅ ಪ್ಯಾರಿಟಿ ಚೆಕ್, ಇಫ್ ಡೇಟಾ ವರ್ಡ್ ಇಸ್ ದಿಸ್, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಅದೆಲ್ಲ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಐ ಜಸ್ಟ್ ಗೋ ವಿತ್ ದ ಕ್ವೆಶನ್ ಓನ್ಲಿ. ಓಕೆ, ಸೊ ಸಿಂಪಲಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಒನ್ ಕ್ವೆಶನ್ ಆ್ಯಂಡ್ ದೇ ಹ್ಯಾವ್ ಆಕ್ಸ್ ಯು ಟು ಸಾಲ್ವ್. ಫಸ್ಟ್ ಐ ವಿಲ್ ಟೇಕ್ ದ CRC ಕ್ವೆಶನ್. ನೋಡಿ, ಇಲ್ಲಿ ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಎಕ್ಸ್ ಕ್ಯೂಬ್, ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್, ಎಕ್ಸ್ ಇಸ್ 1 ಆ್ಯಂಡ್ 1 ಅಂತ ಹಾಕ್ಕೊಂಡು ಇದರ ಮುಂದೆ ಯು ಶುಡ್ ಗೋ ಆನ್ ಸ್ಟಾರ್ಟಿಂಗ್ ರೈಟಿಂಗ್ ನಂಬರ್ಸ್. ನಂಬರ್ಸ್ ಹೇಗೆ ಬರೀಬೇಕು ಅಂದರೆ 1 0 0 1 1 0 0 1 1 0 0 1 ಆ ಥರ ಬರೀಬೇಕು. ಸೊ ವೆನ್ ಯು ಡೂ ದ್ಯಾಟ್, ಫಾರ್ ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಯು ವಿಲ್ ಗೆಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ 1 0 0 1. ಸೊ ದ್ಯಾಟ್ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ಆಮೇಲೆ ನೋಡಿ, ಜನರೇಟರ್ ವ್ಯಾಲ್ಯೂ ಆಲ್ಸೋ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಇನ್ ದ ಕ್ವೆಶನ್. ಐ ಹ್ಯಾವ್ ರಿಟನ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಬೇಕು ಅಂದರೆ, ಇವಾಗ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಐ ಹ್ಯಾವ್ ರಿಟನ್ 111. ಇದನ್ನು ಸೇಮ್ ಇದೇ ಫಾರ್ಮಲ್ಲಿ ಬರೀರಿ, ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ 1. ಓಕೆ, then you'll get this value. ಜನರೇಟರ್ನ 3ನೇ ಯಾಕೆ ತೊಗೊಂಡೆ ಅಂದರೆ, ಬಿಕಾಸ್ 2 is there and 1 is there. Like that also you can take. But ಈ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ it will be better. Okay, and simple again you are going to divide same thing. ಇದನ್ನು ಇಲ್ಲ ಬರಿತೀರಾ ಆ್ಯಂಡ್ ಇದನ್ನು ಇಲ್ಲಿ ಬರಿತೀರಾ. ಎಕ್ಸ್ಟ್ರಾ 2 zeros ಮಾತ್ರ ಇಲ್ಲಿ ನಾನು ಹಾಕ್ತೀನಿ. ಯಾಕೆ ಬರೀ 2 zeros ಅಂದರೆ, ಜನ್ರೇಟರಲ್ಲಿ ಪವರ್ ಎಷ್ಟು ಬಿಟ್ಟಿದೆ ಅಲ್ವಾ, ಇಲ್ಲಿ 2 ಇದೆ. ಸೊ ಬರೀ 2 zeros-ಅನ್ನು ನಾನು ಆ್ಯಡ್ ಮಾಡಬೇಕು. ಆ್ಯಂಡ್ ಯು ವಿಲ್ ಡಿವೈಡ್. ಸೊ ಲಾಸ್ಟ್ಲಿ ಒಂದು ಫಾರ್ಮುಲಾ ಬರೀತೀರಾ, ಕೋಡ್ ವರ್ಡ್ ಈಕ್ವಲ್ ಟು ಡೇಟಾ ವರ್ಡ್ ಪ್ಲಸ್ ರಿಮೈಂಡರ್. ಸೊ ಅವಾಗ ಏನು ಆನ್ಸರ್ ಬರುತ್ತೆ ಅದನ್ನು ಇಲ್ಲಿ ಬರೀತೀರಾ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ಐ ವಾಂಟೆಡ್ ಟು ಟೆಲ್. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಕ್ವಶನ್ ನೋಡಿ, ಇಲ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂನ ಕೊಟ್ಟಿದ್ದಾರೆ, ರಿಸೀವರ್ ಸೈಡಲ್ಲಿ ಅದು ರಿಸೀವ್ ಆದರೆ ಹೇಗಿರುತ್ತೆ ಅಂತ. ಸೊ 7 11 12 0 ಮತ್ತು 6ಗೆ ನಾವು ಫಸ್ಟ್ ಬೈನರಿ ಫಾರ್ಮಲ್ಲಿ ಬರೀಬೇಕು. ಸೊ ಬೈನರಿ ಫಾರ್ಮಲ್ಲಿ ಬರೆದಾಗ ಇದೆಲ್ಲ ಬರೆದಾದ್ಮೇಲೆ ಇದಿಷ್ಟರಿಂದು ಏನು ಆನ್ಸರ್ ಬರುತ್ತೆ ಅಲ್ವಾ, ಅಂದರೆ ಇದು ಈಗ 7 + 11 + ಇದೆಲ್ಲ ಮಾಡಿದಾಗ ಒಂದು ಆನ್ಸರ್ ಬರುತ್ತೆ. ಅದನ್ನು ಕೂಡ ಬೈನರಿ ಫಾರ್ಮಲ್ಲಿ ಬರೀಬೇಕು. ಸೊ ಬೈನರಿ ಫಾರ್ಮಲ್ಲಿ ಬರೆದಾಗ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ಒಂದನ್ನು ಯಾವಾಗಲೂ +1 ಹಾಕೋಬೇಕು, ಯಾಕಂದರೆ ಕ್ಯಾರಿ ಬಿಟ್ ಆಗಿರುತ್ತೆ ಅದು. ಸೊ ಆನ್ಸರ್ ಬಂದಿರೋ ಆನ್ಸರಿಗೆ +1 ಮಾಡಿ ಕ್ಯಾರಿ ಬಿಟ್ ತೊಗೊಂಡು ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದ ಕಾಂಪ್ಲಿಮೆಂಟ್ ಆಫ್ ಇಟ್. ಆ ಕಾಂಪ್ಲಿಮೆಂಟನ್ನು ಆನ್ಸರಾಗಿ ಬರೆದ್ರೆ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಚೆಕ್ಸಮ್. So all data plus checksum is all ones. Checksum will always have ones. So ishtu bardre your second module is going to end, and I hope you liked it. I've tried my best in explaining. If anything you want to ask, you can ask. And all the best. Let's meet in the third module.